Today I want to talk about the equations of motion. There are 5 different equations which I am going to deal today, and these 5 equations we are going to prove also. What are they? Let's talk about them. First equation is A equal to V minus U by T, and second equation is V equal to U plus AT, and third equation is S is equal to U plus V by 2 into T. Fourth one is S equal to UT plus half AT square. And fifth one is V square equal to U square plus 2AS. These 5 equations are called equation of motion. In some of the books, few of them is not taken as equation of motion, but all of them are used to solve the numerical problem related to the motion of the body, and this is linear motion. Okay, how this equation came? Before that, I want to talk about the symbol used in this equation. Okay, let's talk about the symbol used in this equation. There are 5 symbols. What are they? S, U, V, A, T. You can remember this as Subhat or UTSAB, Utsav. Remember this name, either Subhat or Utsav. Okay, S is distance travel. U is initial velocity. And V is final velocity. A is acceleration. T is time. The meaning of this symbol is this. I mean to say, these are symbols, these are the physical quantities. Now I want to mention the units of each of them also. And I'm taking SI unit. Distance is measured in meter, and initial velocity meter per second, and final velocity also meter per second. Whether it is initial or final, both of them are measured in meter per second. Acceleration in meter per second square, and time taken is measured in second. These 5 symbols are used in these equations. Now let's start to prove each of them. Let's talk about the first one. First one is rate of change of velocity. Rate of change of velocity is acceleration. Now, first one comes from this definition. This is the definition of acceleration. The rate of change of velocity is called acceleration. If it is so, then we know that change of velocity means final velocity minus initial velocity, v minus u. And if it is divided by t, then we will get rate of change of velocity, and this is acceleration. This way, with the help of the definition of acceleration, we'll get this equation. Equation number first is proved. Now let's talk about this second equation. From equation 1, from this equation, if t is taken to left hand side, then we'll have at is equal to v minus u. And if u is taken to left hand side, negative sign becomes positive. U plus at is equal to v. Therefore, v equal to u plus at. And this is second equation. That's why this second equation is also proved. Now, we are talking about third equation. Third equation is completely different than first and second, and is not related to first and second. So, let's talk about third. I want to take one example, and then I want to start this third. Let's say a body is moving this way. At first, it is at rest. Its velocity is 0 meter per second. At the end of 1 second, its velocity, let's say 5 meter per second. At the end of another 1 second, let's say 10 meter per second. And in the same way, 15 meter per second and 20 meter per second. A body is moving in this way. It means what? This body is in uniform acceleration. And if we have to take single velocity for this motion, then what to take? This is a little confusing. Whether we have to take 20 meter per second or 10 meter per second or 5 meter per second or 0. So the average velocity is taken to solve the numerical problem, and the average velocity for a uniformly accelerating body is taken as the sum of the initial and final velocity divided by 2. Initial velocity in this case, in this particular case, initial velocity is 0, final is 20, and if 0 plus 20 is divided by 2, then what we get, that is the average velocity. Now I want to name this equation as A. Now second point, a body is, if moving in this way, or we can say a man is running in this straight path, let's say, whether a body or man, same thing. If this path, length of the path is 100 meter, and if a person start to run this 100 meter length, and if he finish this in 10 second, if he finish this 100 meter race in 10 seconds, then what happens? Actually in first second, probably he will cover only 2 meter distance, but in second he will cover more distance, maybe 4 meter distance. But when he speed up, at last he will cover very long distance, maybe 15 meter distance will be covered at the end, I mean to say 10th second. It means its velocity, if this is a person or this is a body, then its velocity in first second is 2 meter per second, but in last second it is 15 meter per second. Which velocity is considered in the numerical problem? Which velocity we have to take to solve the numerical problem? Here also we have some confusion. That's why in this case also average velocity is taken as total distance covered, which is denoted by S, divided by total time. Total distance 100 meter is, if divided by total time taken to cover this 100 meter distance, then its velocity will be 10 meter per second, and this is actually average velocity. That's why average velocity is not only u plus v by 2, but average velocity is equal to s by t also. That's why we can write this as b. And combining equation A and B, s by t is equal to u plus v by 2. Therefore, s is equal to u plus v by 2 into t. This is equation number 3. Equation number 3. Third equation is also proved. This way, distance covered equal to u plus v by 2 into 2 into t is proved. Now let's talk about the fourth equation. Now I want to prove fourth equation. For this, you have to remember that we are going to substitute this v of this third equation with the value of v from second equation. Substituting the value of v from equation 2 in equation 3. Now what we are doing? In third equation, s is equal to u remains same, but we are taking a u plus at in place of v. That's why u plus at. Now 2 is same into t is also same, or s is equal to 2u plus at by 2 into t, or s is equal to multiplied by t, 2ut plus at square divided by 2. If we separate this, 2ut divided by 2 plus at square divided by 2. 2 to cancel. Therefore, s is equal to ut plus half a t square. This is equation number 4. Equation number 4 is also proved. Now I want to go through equation number 5. What is it? How to prove this equation number 5? Okay, in case of the equation number 5, what we are doing, from equation 1, this is equation 1, if a equal to v minus u by t, then t is equal to v minus u by a. And let's say this is equation C. This is not in series, that's why writing different name for this, that is C. Now substituting the value of t from equation C in equation 3. Now what we get? We have s is equal to u plus v by 2, the same, but in place of t we are taking v minus u by t. That's why v minus u by t, v minus u by a comes here. Okay, or s is equal to u plus v, and v plus u are same. V plus u, I am writing v plus u by 2 into v minus u by a, and this is a plus b into a minus b. It seems to be a plus b into a minus b. That's why we can write s is equal to a plus b into a minus b is equal to a square minus b square. This by 2a, or if 2a is taken to left hand side, 2as, this is equal to v square minus u square. If u square is taken to left hand side, then u square plus 2as is equal to v square. Therefore v square is equal to u square plus 2as. This is equation number 5. Look at this. I proved this 5th equation also. We have altogether 5 equations. Each of them is proved one by one. Okay. Now in next class we'll talk about them again, but at that time we'll prove this 4th and 5th equation, which are highlighted differently. I mean to say, you may be asked in examination to prove s equal to ut plus half at square only, or you may be asked to prove only v square equal to u square plus 2as. It will come in next class. Okay, this much for today.